Esta conferencia comenzará a grabarse.
Now.
Okay. My name is Jouke, or Jack, from University of Antwerp, and I'm together here with a colleague, Jochen, who you cannot see because you can see my presentation. And we work now for about 3 weeks or almost 4 weeks on respiratory or face masks based on a local question that our academic hospital had. And but we have a lot of expertise in 3D printing and so forth. So I just wanted to share something and also come up with a proposal to discuss. So the main item, and this is not a lecture about 3D printing. So that's for another time. So I just in short, I think this is in one slide what's appealing of 3D printing and why many people here are working on it. So if you look also in the book from Hot Lipson some time ago, which is called Fabricated, you see it's you have 0 lead time, so immediately you can manufacture stuff. You have 0 skill manufacturing, so you can just press a button and it will you will get whatever you need. It's compact. It's not like you need a factory hall or special equipment or air whatever. And it's also very precise in terms of replication. So these are some of the benefits or the intended benefits of 3D printing. And in a sense, most of them are valid also for other digital fabrication techniques like laser cutting and so forth. So also in textiles, digital textiles, similar kind of things. So and it leads to two important things, which are the fab labs or the maker spaces and so forth, which you have in very different variants from people at home towards people in industry versus people in academic maker spaces. And then you have service bureaus, which are basically like print farms that can create a massive amount of products based on the benefits that you see on the left. And of course, this leads, as also from a citizen point of view, this leads to a democratization and of production and also of localized production. So we can do stuff back here in an easy way. We don't have to transport a whole factory from China back to here. We can just copy and paste it. We download it from the internet. So that's the promise. There's a but. So if we talk about materials, I think you all know there are many materials that we cannot print or we cannot manufacture with 3D printing. So there's a limited amount of materials that we can do. And also there's limited knowledge and control of that materials. So if we talk about the medical field, there's really a very small amount, a very small volume that we can actually use. So similarly, there's a limitation in what we can do with material structures, the microstructures. So we have a lot of academic studies on this, and there's a lot of advantages of 3D printing, but definitely it's different than other production techniques. And then also, so there's limitations in geometries, also in the printing volume that you can get. It's not easy to print a whole human being, for example, in plastic and so forth. And I think what sometimes is forgotten if you talk about large volumes, and that's maybe some of the challenges that we now have and face, it's difficult to do that in a good way with 3D printing. So, and then there's quality control in the design. So normally in an industrial design process, there's a lot of version management and so forth. It's not always the case with 3D printing, and you can download whatever, but you don't know what it is. And similar to the process. So these are just some, and there are more constraints, which from a designer point of view are challenges, and we want to solve them. So we're a school of design here. So some examples of things that are published on the internet now, if you talk about face masks. So here you can see one that is fabricated with SLS or MGF technologies from HP or selective laser sintering in polyamide, in nylon. And it looks wonderful because it's basically just a very simple thing that you can print, and then you attach a very simple HEPA filter on top of it. But you can be sure, because there's a limitation in material structure here, and that actually this structure, this nylon structure, is actually porous, and it's even in most cases more porous than the filter that you use. So then it gives a false sense of protection. Similarly, if you use this kind of masks, the fit to the human body is key. So if you just print whatever you have on the internet and think that would be good for a health professional, it will not pass the regular tests that are there to make sure that you have a perfect fit. Similar with other ones, like this, so this is one which is printed in a fast way by fused deposition methods, so the simple 3D printers, and then you can more or less fold it. Also with a HEPA filter, you can imagine that this also gives more problems than solutions in a sense. And so now on the right, you can see a product that we're now also evaluating based on the Decathlon mask, the Easy Breeze. And on the one hand, it's a very appealing solution because this is something where you have something which is meant for scuba diving or snorkeling, and you just attach a 3D printed adapter at the end, and then a filter, which is a HEPA filter, or a filter from a ventilator. But basically, we have a lot of problems in the measurement with this particular product. It is not airtight. It's meant to be used underwater, and that's different than if you use it in air conditions. And we're getting into the depths of this, but basically we cannot really approve this method. And then another one, this is the one from the TU Prague in Czechoslovakia, Czech Republic, which was published also as a solution for a FFP2 mask with a ventilator valve in the front, and then two filters on the left and the right side. And the problem here is the exhalation valve in the middle, because the 3D printed structure does not really give an airtight solution to the silicone membrane which is inside. So again, if you have to have a filter which filters everything up to 0.3 micron, which is the standard for N95 or FFP2, that will not happen if you have a 3D printed one, which if you look carefully, there's staircasing, and you would never able to fill up the gaps without any post-production. And if you do post-production, then it really has to be done really, really carefully. So I hope these are just some examples of things that are now on the web, which on the one hand give a lot of promise and hope, but on the other hand, some of that hope is false. And so my main thing is that we need to have some kind of function, and it might be at the end of the day, it's certification, but that's just way too slow, way too slow. So we need another system. And then from an academic point of view, I come to the idea of having a peer review. So we have other people printing the same thing and assessing how it works or how it doesn't work. And then we gather that evidence, just as we do in the scientific field. And yesterday I found a nice example how this actually is working for personal protective equipment in the United States. And of course, the United States has a different structure than Europe. And there you have this initiative called America Makes. And every state has a number of America Makes laboratories with experts. And sometimes they're from industry, sometimes they're from academia. And they're the point of contact for this. And then at the right side, you can see that there's the the FDA and the NIH, the National Institutes of Health, that are more or less consolidating and certifying bodies. And then in the middle, you have this Veterans Association, the VA, which does this validation and testing. And all of that testing and validation is also shared through a portal. And I thought, well, okay, this is a structure that more or less can be copied, and it will not be the same. But at least with this, we can make sure that if there's designs, then people can upload them in some kind of way and also can see whether it really works or not. And if it works, that at a certain point you can also you can see the evidence of that. So if you go to this particular website of the NIH in the United States, you can now see this NIH 3D print exchange. I'm not sure whether you're already familiar with this. So if you do, then the rest of the presentation can be very short. Basically, they have an upload facility. You can submit a prototype, and then it will be peer reviewed, more or less, by the Veterans Association. And then they offer 3 different categories for the designs to be shown. So either you have designs that are already reviewed, or more or less approved. And this doesn't mean that they're already certified. This is a pre-certification thing. Then you have prototypes in progress, and then if you click on those, you can also see the actual state of those designs. And then there are more or less designs that are not as safe as we might think they are. So these are the designs with safety implications. And my proposal is to have a similar kind of structure here. So what we see is that there's a lot of Google documents, open Google documents, that a lot of people add up nice scientific publications, and they add up designs, and some of the designs are then also put on websites like Thingiverse or a similar kind of open source parts, libraries. But there's no such thing as a control mechanism here. And so my proposal would be to do this in some kind of way based on academic makerspaces with a medical link, and also with a certain expertise in metrology. So things need to be measured, things need to be assessed. So this is not an average fab lab in a library. And then it needs to be resilient. So there need to be multiple ones of those, just to make sure that it's this kind of peer review can be done in a relatively short time. And this needs to be in contact with the real certification bodies. So these notified bodies or whatever they're called, because we also feel that right now there's a link missing to these institutions. And for example, here in Belgium, we have to now evade to laboratories or to notified bodies in Germany. And I'm sure that the laboratories in Germany are quite busy with their own kind of thing. So right now, this established contact is really important. This is the first proposal. And then furthermore, I think because we have 3D printing, we can also embed like text or codes in the 3D prints. So we can embed more or less the traceability as we would like to have with medical products. And that would be very easy to do in general. And another thing that is important is the material sourcing and clearing. So if you think about all the designs that are now online that work with the HP printers, for example, so the multi-jet fusion systems, there's only one party that's very happy with that, and that's HP, because they sell a lot of the powder, and they're in the next 8 months they will continue to sell that. But I'm not sure whether we have a good negotiation position with HP if all of us are doing this by ourselves. And similar with filtration material. So if you look at the respirators, you need filtration material like HEPA filters and so forth. And if we are all trying to get that material, then again, the markets will just jeopardize. So that's my presentation. I hope it was clear.
Yeah, thank you.
I think it's very good proposals, but I will let the experts make their statement. Comments, question, what do you think?
I have a few.
Please, sorry. When you speak the first time, please present yourself briefly, very briefly, just name or organization, okay?
Okay. Thank you, Antonio. So just to present myself briefly, my name is Cesar. I'm working with Coronavirus Maker here in Spain, and I have been doing a literature review with Miguel Angel just to try to consolidate knowledge about the topic. And so I think the idea of peer review is super interesting and it could be quite useful. I'd like to know about how do you plan to integrate doctors. Yesterday we had a meeting with the Spanish Agency of Medicament, so they are the ones that are supposed to be in charge of the approval process of every kind of medical device here in Spain. One of the things we got from the meeting is that some doctors on the field in hospitals, for example, they were talking about the Easy Breathe mask that you were talking about from Decathlon. They were seeing an improving of like 70% of patients would benefit from that. And I'm wondering how, because so far what I've seen on peer review, it felt more like materials and in some way some trial of the technical aspects of the materials itself. But I think in the current situation, we should also incorporate the feedback from clinicians on the field because they are the ones that could provide information about what is being useful or not. And I think that that is one of the key aspects we need to consider right now. Okay, maybe this is not the perfect solution, but maybe this is saving lives. So I think incorporating the feedback is one of the important things to do here, even in the peer review part. And on the other hand, I'm also in contact with the FabLab network. Yesterday we had a meeting with other peers in the network, and they are doing some basic research at the Center of Bits and Atoms at MIT. I think we could contact them if we want to test. I'm just thinking about Miguel Angel that is sharing some images on just trial on laboratories. I think we could connect with them to do some trials with particularly expensive or hard to acquire equipment. So if there is some kind of trial, I think we could connect with them, and this could be useful for the whole ecosystem.
So can I respond?
For sure.
Yeah.
For sure.
So first, of course, as a professor in digital fabrication for 18 years now, I'm also well connected with MIT, and I know Neil Gershenfeld very well. And we go to the same conferences, and I'm not alone by that. So there's many scholars in Europe, like in France, like in Germany, in the UK, especially in the UK, by the way, that have similar kind of knowledge and also similar kind of equipment, and are also very networked together. So again, so if you talk about resilience, I think it is about making sure that we know where these kind of pockets of, or these centers of excellence actually are. And I agree, so also the point of view of technicians is very important. As I said already, so for example, our research here is done completely integrated with the academic hospital that we have. And the academic hospital also does trials with our equipment. So that's one. And the other thing, so with regards to the specific design of the Decathlon, this snorkel mask. So there's two applications here, one for the patients and one for the healthcare professionals. For the patients, we don't foresee any problems because then you have already a person that is contaminated and basically you use it as a full face CPAP mask. But for the health professionals, we cannot guarantee that the fit and so forth is really good, because in our tests, and we did now about, well, that's at least 10 or something like that, it really performs very bad. So it gets a performance score in the Porta count, which is a general test for the fit, of about 6, and it needs to get a Porta count score of about 100 or 200. So basically that means it's leaking. Basically that means that viruses can get inside.
Perfect. Thank you. Could we give the word to other participants? More comments from other countries, perhaps?
I just would like to ask to Juk if that information, there's any paper about this leaking test, if we can have it, or it's free, or where I can find it, because I think that this is very, very important to let people know, because here in Spain, everybody now it's crazy looking for that kind of mask. And I will show my presentation right now. You will see that we are working on that, but people think that this is the next solution.
So the measurements that we did were from yesterday. So this is very fresh. And of course, we will have a press release ready as far as we really also understand what's wrong, because maybe there's an easy solution. Maybe it's just putting some tape on a particular place. So, but indeed, it's a very important thing to have to share with most of the people as soon as possible.
May I add something, please? Here in Portugal, we try to adjust different models and different types of materials to different uses. For instance, in the hospitals, when they're really needing and they have no alternative, they are using those most easy face masks. They're so quick to produce. Hundreds of them have been already produced. In this conversation, there's Tiago Lourenço, who's leading one of the groups that has produced a lot, but also for firemen, policemen, security people. They have to face people that they don't know. Sometimes they have to approach people very closely because they need to do that. So they need to be protected, maybe not on the same intensity as the doctors or the people that is ill, but all of this is needed. So whatever you are able to do, more let's say more scientifically validated, or even less, is needed. Of course, for the use in the hospitals, you have to have the input of the homologation authorities, and I hope everyone does that.
Yeah. So just so in
Antonio, sorry, may I add?
Sure.
May I add something that I have just realized? When we are collecting all the information, and I think one of the points that Duke made is quite important here. So far, we are documenting how to 3D print, assemble, and it's most of the information available right now in Thingiverse and all places. It's like the pieces are kind of neutral. I mean, it's like take this piece, use it everywhere. But I think if we need to move to the next stage, we should also document the use cases. That this is something the agency talked yesterday. Like, okay, this piece in this context for this particular user makes sense or not. Like he said, maybe the masks are really good for patients, but really bad for clinicians. So we should try to kind of certify or peer review these kind of use cases. It's not like the mask itself, it's like the mask for this particular user in this particular context, because otherwise we are going to get a lot of confusion. Like some people take the thing for the patients and use it for the doctors, and this is not going to work. So I think we should try to provide this kind of information in every time we work on the use cases. for the pieces.
That's right. That's true for every kind of material, 3D printed or not. The same happens with the ventilators. We've heard the Italian people here in this forum some days ago saying that they were preparing that even for professional equipments that are produced by the large companies for years. If they're not used correctly, they can kill people instead of saving. So everything that is used on people of risk has to be more validated.
Thank you very much. I would like to hear other opinions from other countries, because this is I think a very important proposals, and I would like to know if we are able to create a European network on this proposal. So please.
May I?
Yes, good morning. Kozikov from Anishay. Do you hear me?
Yeah.
So I have one slight comment on the presentation. I think that we have to be careful when we announce that kind of thing, because I think that here we are more talking about Fab Labs results or parts that you can achieve on very small printers. Because when I read things like zero skill manufacturing or something like that, I totally disagree with that kind of speech, because well, we are producing parts for aerospace, for defense, for automotive. We are producing flying parts for Airbus, for example, and I can tell you that this is not a zero skill manufacturing. So I think that you have different steps and different level of parts manufacturer in 3D printing or additive manufacturing. And it seems that you are only talking about Fab Labs level. And that's something which is quite a concern for me, because I do not agree with the presentation or the way it is presented. Because I can tell you that when you are talking about flying parts, you are able to make all the process chain, and then you are able to prove the quality of the parts, to prove the metrology, to prove the metallography, to prove everything. So I think it's quite restrictive presentation.
May I respond?
For sure.
Antonio.
No, Vasco. Sorry, Vasco. Let Joe answer, please.
No, so thank you, and no, it's a fair comment. So on the other hand, I think if we talk about what's happening today, is not so much what's happening in the best service bureaus or the best industrial manufacturing facilities that are around. This is really about makeshift personal protective equipment. I work together with a lot of industrial systems and industrial makers. I work with a lot of metal manufacturers as well. But I think this is not about discrediting professionals, but this is really about making sure that whatever is there, what we make available for the European citizens is at least consolidated in one way or another.
I understand that we are speaking about a urgent situation, and that for sure we are not speaking about the industrialization processes that for sure can be far more advanced on testing and designing on materials and so on. So we are speaking about organizing a voluntary network with the minimum level of quality. I think this is what we are speaking about.
Yeah, and here, so this is just an example. So this is made by an industrial maker. So this is made with an HP multi-jet fusion printer. So this is as a mask. It looks very well, and it's also a little bit flexible. But the material that you see is more porous than the filter here. And you can only make this if you have a machine that it's 200,000 euros. So this is not just for small makers. This is also something that is now promised by some of the industrial maker spaces or industrial manufacturers to be a solution.
Absolutely, I totally agree on the fact that we have to prove the quality of the parts. What I was mentioning is that everybody is not doing, I mean, things without thinking about the consequence or about the fact that the parts has to be qualified. So that's to, I think that the presentation was quite direct on that point. But of course, we have to be careful with what we are producing, and if it encounter all the biomedical aspect, for sure.
Thank you. More comments?
Hello, this is Rui Soares from Engineering and Tooling Cluster in Portugal. I would like to address here one or two aspects which I believe are important. I enjoyed the presentation. I think it's by Duke. It's very good. I think this effort is very good also in the sense of trying to condense the aspects of regulation and the design. I think it's a counterproductive thing, unfortunately, that is happening, of too many people trying to help, of course, which is positive, but a lot of designs are being created and options, and this goes against, I would say, the main objective of everything being together to try to fill this gap of having the amount of components that you need using 3D printing. I'm in a representation of a cluster which deals with 3D printing for a long time. We call it first rapid prototyping, then additive manufacturing. I've been working on this since 1998, but also in the part of the more large-scale manufacturing using molds and plastic injection. And here is probably where I want to most address. So one of the aspects that were addressed in the presentation by Duke is, of course, most people for sure know here, is the aspect of volume of production. So unfortunately, if we are dealing, such as in this case, with the probability of needing of a lot of amounts of this equipment, we need, I believe, to go from this aspect of production in fab labs to more mass manufacturing. I mean, doing molds and injection molding. And I think this is something that has to be taken in account when doing this design, I would say, of this type of mask for this use, because it's an opposite thing. The freedom that we have with 3D printing may be counterproductive for the use in more large-scale manufacturing using molds and injection molding. So what I mean by this in simple terms is that I have so much freedom in 3D printing that I can be designing something for 3D printing which is not possible to be reproduced using a mold in a an injection molding in a more large scale. So I think it's needed also to be taken in account, especially in the part of design and also in the aspect of materials. But here there's a benefit in materials because you can have more adequate materials, I would say, more large option of materials by using injection moldings. But the aspect of design, I think it's crucial. If you think at a medium scale, okay, you can do it in 3D printing, but if you want to scale up this production, you have to take in care the design of the part, especially the design if it's doable or easily doable, because this is the problem. We want to have in a fast way, a large number of these components. Okay, it's just to address this.
Thank you very much. More comments.
Antonio, sorry to interrupt, but I think the idea of having the peer review, I think would be very interesting to pursue. That's my comment.
Thank you, Vasco.
I just sent you my presentation, Antonio.
Okay, thank you, Aurora. More comments? There is a lot of people.
Okay, can you hear me?
Yeah, we can hear you.
I want to share you my screen.
Just one moment. I need to give you the
permission. Right. Can you see it now?
Not yet.
Okay, now I need to. Okay, right now, yeah. Does it work?
Yes. We are.
All right. All right. So we've been quite successful in mass producing face shields, as they are in Lithuania. I am Paulius Brėtis, founder of School of Robotics, and well, face shield making is quite a popular subject and probably the easiest right now. And thank you for this website. I will upload our designs here as well. And this is the most popular topic here I see too. But what we've been successful in making is producing them en masse. There was a local fund which created a fund of 1.5 million euros from private persons, and over the start of the quarantine, in 1 week, we've made around 80,000 units of those face shields for Lithuania alone, by making them easily folding from one piece, and now we are cutting them with mass production tools, basically, being able to make around 40,000 units per day. So that's how they look. Basically, they cover both the top and the sides, and we've uploaded designs freely available. There were some 3D printed designs that were simple to use for even small printers, as well as this single piece cuttable design. There were a lot of laser cutters who joined in freely, and this kind of solved this design kind of solved the materials problem also. We actually bought all the PETG materials around in Poland, Latvia, and Lithuania, and some in UK, when a local food, well, there was a company, Retail Baltics, which is making food grade plastic, and they have modified their design voluntarily and are now providing tons of plastic material, around 50,000 tons a week they are able to produce, and we have right now no shortage of this clear plastic for face shields, and we don't need any 3D printable parts anymore. So if we join in a couple of more machines that are stamping those, we can produce around 500,000 a week, and they are very well cheap to produce. While the first offer to local hospitals of face shields were 15 euros per unit within 10 days lead time from China. So this is a kind of a successful story when a hospital has an innovation department that is constantly asking for something to be made, and a local makers fair is responding, and we were as well. Right, they have also asked us to make a UV face mask disinfector. That was also made by a local maker from a simple UVC lamps made for aquarium disinfection. They have also, yeah, and right now we are focusing on thinking of oxygen concentrators, which could allow which usually allows people to be let out of the hospital earlier home to use this oxygen concentrator for their for the healing. So yeah, basically that's what we as a team done, and we've already provided around 80,000 of those shields. And even yesterday we had a TV studio. Yeah, where is it? Yeah, this is a Minister of Education, and in the TV studio, all wearing those shields, promoting this new kind of, I would say, a fashion of this spring. Yeah.
Congratulations, congratulations, Paulus. Just one question: is this validated by the health authorities?
As this was, well, as this is an extreme situation, all the hospitals are able to buy supplies by themselves, and they only took a look at it and said, yeah, that's good, we're buying it. Then the local Lithuanian army started buying. We have reinforced the design, we have strengthened some parts of it, and so on, and we have a new one somewhere. Yeah, that's the new design. And we were never asked for any validation, only that a couple of doctors have told us that it's good to use for them, and that was enough, and we started making and giving out and even selling them at low cost.
So it's validated de facto.
Yeah.
Okay. Thank you very much. I was trying to continue discussing about the proposal from Joke, because I think it's very important to comment it, but perhaps it's good to jump to the presentation that we had and return later to your proposal, Joke, if you have time to stay, because I think...
I have time. At the same time, I want to make sure that, so certification, as you already stressed, is one thing. The other is the WHO guidelines. And the WHO guidelines, even for the face mask and the face shields, even for the scrubs, even for the aprons, have particular kind of specifications and constraints. So even if there's no medical doctor requiring something, nobody should be without these kind of WHO documentation. And another thing, just briefly, is that of course we were also asked to look at UV sterilization and so on. And there's a lot of issues with sterilization based on light. If you talk about masks, basically there's no guarantee that it will help, and there's no medical, there's no scientific proof of that.
We found one research that found 3 times decreased risk of contamination using a face shield. And a face shield needs additionally a respirator, but it can also prolong the use of a respirator by safeguarding it against direct contact with liquids. We found this research within a forum group shared.
So we are in direct contact with the Institute of Tropical Diseases, which is also in Antwerp. They focus on Ebola, on other pandemics, and they just gave us a no. Don't do it.
Yeah, the problem could be that we could create a false sensation of security. I think that's the main problem in my point of view. Okay, but we will continue speaking about this. Alvaro, could you share your
Antonio, just a second.
Yeah, Ula. Yes, for sure.
Okay. No, very briefly, because I'm not sure how long I will be able to stay with you guys. First of all, I think what Jauke presented is extremely important, and the discussion on this also false security is something we have to take quite serious. So what I will do, I will take also the information back and feed it into our discussions which we are having here, on one hand setting up a clearinghouse, but also to see how can we help with this peer review report and reporting and setting up this kind of network, because we have similar discussions also on the different solutions proposed, how to go about it. And when I was thinking, Jauke, what you said, that it has to be linked on one hand with meteorologies, and I think there I will reach out in the JRC and particularly in Belgium, because the JRC is a joint research center of the European Commission, and the institute which deals most with meteorology is in Belgium, in Gale. So I will also reach out to them to see whether we can maybe also activate them as a European research center, and maybe also try to link them with you, Jauke. I mean, I know them, I worked there before, so that should be easy done. But I think this is definitely part of the equation we have to take into account. Thank you.
Perfect, Ulla. And would you support us or support the network in contacting with not only with whoever is necessary to involve? And next question, what will be the next step? Will it be good to agree on a next meeting in, I don't know, soon, very soon, tomorrow, I don't know, for this kind of experts, just to discuss how to put this in movement?
Yes, I think we should have a follow-up, but leave me the time during the day that I can see who I can activate, what are the best next steps, and I come send back with more information, either tomorrow or in writing to you, Antonio.
Perfect. Thank you very much, Ulla. Okay, we continue. Álvaro, your turn.
Hello, good morning. I'm gonna share my screen, okay?
Yes, I will give you the...
Yeah, please. For those who doesn't know me, I'm talking for the coronavirus makers from here from Spain. This, okay. Compartir.
Now we see it.
Yes, now you see it? Okay.
Yeah.
So in fact, they told us that we should talk about our movement, who we are, how we work. First point that it's an open movement. Okay. So let's start. What is coronavirus makers? That's something that everybody is asking us. The media is calling us. People in the internet around the world is asking us who we are, who is behind us, and how
Álvaro,
we organize. Yes.
Sorry, Álvaro. The screen is, at least for me, is out of the scope. You should reduce the text. Something like that.
So,
yes, please. Keep it that. Keep it that way, because
sorry?
if not, yeah, that's right. Please.
Yeah, that's right. Okay.
Yeah. Please be brief, because we don't have a lot of time. Sorry.
Okay, I'll be brief then. So, in brief, we're a volunteer network. We work as a team. We are in our Telegram group. We are 16,000 people. And what we do, we just do research and produce individual protective equipment because there is a lack of it in the market. And our Spanish government doesn't have the media, and the industry doesn't produce it. So we have to do something for our healthcare systems workers and other workers, of course. So we joined together and we started to work in small teams. So mainly we have a self-organized movement without legal form. Okay, that does mean that it means that we are no an NGO, no company, no foundation, nothing. We're just people working together as a team. Okay. So how it started? It started with a dream. It called it the Resistencia team. They are working on a respirator. Okay. In fact, yesterday the meeting with the agency responsible of medical devices, it seems that this is the most advanced medical device. Okay, and it's done by makers. and they are doing testing with animals, all following all the clinical trials. And it founded on the 14th March. Resistance founded 2 days ago, and they say to the community, hey makers, we need to produce some a part of the device and we need your printers. Could you help us? That was the first dream. And in fact, when I saw it, it was, oh, that's very crazy, but let's check it. And the project evolved, okay? But that's another story. Nowadays, we are 60,000 visits in the Telegram links. As I told you, we had 16 people on the channels. People, it's talking every time, and sometimes it's very, very crazy. In the first week, there was a lot of message, and now we have from the first day we have a forum, and now there are 3,000 people talking in the forum, and we have like around 700 threads. Okay, so people are sharing their knowledge and their findings and asking what for help. What we do? Easy. We design solutions using digital publication tools, like everybody in Europe. Everybody is doing the same. We are not doing anything different. We just get together. We are focused on mid-scale because every single node can work, can produce, for example, 20, 50 face mask, and altogether we have producing. We had produced like 4,100 of masks in 2 weeks. And we working in the analysis of and distribution all the information. Okay, what do I mean with that? We check where there is a lack of equipment. Okay, and then we send that the equipment, we produce it, because we don't have any public information. So part of the job is to see which hospital, which small healthcare center has a lack of equipment, and we just set up the logistic to make it profitable in time, and we send it. And also, and here Miguel, that is with us, it's one of the people who has read more papers. We check all the academic papers. We don't want to go crazy. Everything we do it based on papers. For us, this is very, very important. We don't want anyone to say, hey, I got a solution. Okay, do you have any bibliography or any paper who I can check your findings? Yes, no? Okay, that's very, very important. We don't want to give something that doesn't work, or that gives a fails security, a false sense of security. Okay. In fact, we have a problem with the face masks, and we have to do 2 groups: one for the healthcare workers, another for the people who is working in supermarket or any other store. So, what is the plan? Mainly, the plan is that how we work. In fact, we do some research. We see, we read what is in the academia. Then we prototype. So because we are a maker movement, as you know, it's very, very easy to prototype, iterate, and keep working. We test in the field. We get in contact with the hospitals and say, hey, I know that you have a lot of this. Would you like to try this and tell me if it works or not? If it works, then we go to institutions. Okay, institutions here in Spain, it's very different. We got the central government and then the communities. And in this crisis, each community has told, I like this device, I don't like this device. Could you modify this? Could you not modify? Okay, and then we go to production with all the makers note. So the idea is that give some time in order that the industry starts all the mass production, because the problem here is that we don't have equipment, and people need the equipment to get protection. So while the industry makes all the mold, gets all the setups to do it the right product, we are giving some times. So here, one problem I want to share with you is the validation step. Okay, validation step. If we had some central institution, being from Europe, being from Spain, everything could be much easier. Here the problem is that we have all the regional governments and everybody's telling their what they would like. And if you got the laws, if you got the laws in hand, that's not the. I think that this is wrong, because local government can tell you, okay, I want a medical device like this or like that, because you only have to notify. But maybe I'm wrong. But this is our findings. Okay, I'm gonna tell you about a nice example of how we work. This is a very good job and very hard to do. I totally agree with what Juk told before. It's very important to keep security, but we are in a critical situation. Okay, keep in mind this to understand what we do. We check all the resources. In here, it's a post of our forum telling people how works the aspects of prevention of virus by air, how mask works and all this stuff. Okay, and also we check this is an image, but we check all the biography as we told you. And then we make a kind of brainstorm and we start to working on solutions. Here you see the classical FFP filters, which now it's in Spain, it's a strategic good, and you can find it anywhere. We are trying to move everything, and it has been almost impossible to find just one unit to see how it works. And then someone came with that idea, the idea of a HME filter. Okay, that is something that hospitals have in their stocks, and there is not a lack of stock in the market. So we say, okay, that may work. So we start working with that. And let me move one thing because I want to see the screen. And then we start doing some molds. There's a guy. So because we're a community, everybody knows a little bit of everything. I'm a biologist. Miguel, for example, is physics. There is people who know how to make molds, some casting. So that's the big thing of the movement. We are people who are professionals in our field, and we join our knowledge. And that's, I think, it's a very important thing. There are academics, there are no academics. There is people who know how to work metal, to work latex, for example. Okay, so for example, we get the prototypes here in very fast way. I think that they did it once we get the model. Doing this was very easy for them. And then, as I told you, we go to the healthcare and we check with them. Okay, that doesn't work. Where that doesn't. The first review of that mask, it has a leak problem in the nose. As you told before with the Decathlon mask, we had also this problem. Okay, no problem. Let's do another iteration because we got the files. Here it's very important to be open. If we are not open, we cannot share knowledge. If I don't give you the original 3D model, it means that at some point I will have to recreate it. For example, this happened with the Decathlon valve. The Italian released it STL. Okay, STL can be printed, but for example, one of my teams found that the size wasn't correct. It was we could cut some parts in order to reduce the printing times. So if we had the original files, we could have saved some time. Okay, that's for me it's another important lesson. If you can share all the files, it's not open. This is the tell you the design. As I said, we focus on two ways, on the treatment and the protection. This, in fact, the red one is the model from Airbus. We talk with big companies in order to see if they can help us, if they can support us, what they are doing, and we share the knowledge. We know that they are taking profit from the situation, but we don't care. We are working for free knowledge and to help people who really need it. Okay, and this is our model of the Scuba Max based on the Italian model, and it fits. And in fact, when we release anything when we release something, we give some protocol how to produce it. If you need to make some kind of trick to adjust, like here we say, okay, in that joint you need to put to add some Teflon, just to make sure that there is no leak in that way. Okay, and there's some small tricks that people doesn't know. People think that having a 3D printer at home, you can print this and you can save the world. No, that's not correct for me. But as a community, we try to speak freely, and we try to share that knowledge. Other stuff we have already done. Okay, we're not originals. We are copying. What is the problem? What I told you before. People is sharing knowledge but not files. What does it mean? That we have to start over again or everything. Here, there you see two models of Googles we produced and tested. This is more like for snorkeling, for example, and the idea was to printing with TPE, and this is something that anyone can do at home with a classical FDM printer, and it's much easy to print, and we can have a stock for healthcare workers in a brief time. That was, I think, it was one of our objectives. Here you can see two models of the mask with it, and also the anti-splash box. This idea come from China or Hong Kong. I'm not quite sure, but as you see, all of you know about digital fabrication. This is not the best way to produce it. Okay, because when you try to assemble everything and fix it, you don't have any tab to make it easy. So it's something we redesign it. Okay, that has been part of our work, and I think that's all. We have Cesar here with us, that is our documentalist. Okay, so I think that if you have any question between Cesar, me, and Miguel, who is the guy in charge of the mask, we can ask you everything you need. Thank you.
Thank you, Alvaro. If you don't mind, or whoever wants, we could exchange later the emails and the contact data, just to let you connect between yourselves. Okay. Okay. There were another presentation ready for today from Portugal, Rui Soares, about injection. I don't know, Rui, if you want to present very quickly, please.
No, I didn't send a presentation. Is just give an overview. But okay, I can briefly explain. We have several types of technology in 3D printing at our center in Sentinf, related with the engineering and tooling cluster. And we also are in the area of mold manufacturing and the injection of parts. So I think here is repeat what I said again. It's necessary to fixate all these aspects of the legislation and to have a common ground for manufacturing. Okay, and to see which should be done in 3D printing, and if we should go for more large-scale manufacturing in terms of needing the use of the injection molding. So for this, our cluster, in the engineering tooling cluster, can try to provide support and to provide help in this sense. So basically, is this.
Thank you. And we will close the presentation. Later we will speak about the proposal from UK, okay? But Raul, could you present your tool? Because I think it's will be very interesting to have your presentation.
Yes. So hello everyone, my name is Raul. I'm with Astroprint. We are a small 3D printing company where we specialize in making software for 3D printers. So basically we are going to talk how we can solve some of the challenges that this 3D printing movement that Alvaro just talked about, how we can coordinate all this effort, because some of the challenges that we're seeing is that a lot of people, as you can imagine, we have thousands of people 3D printing parts, but then it's hard to understand what needs to be printed, once those objects are validated, where they need to be printed, how we coordinate the pickup and delivery to the facilities that need those parts the most. So basically, we are developing the tool for everyone.
Raul, sorry, could you share your screen, because at this moment you are not seeing anything.
Okay, yeah. So I also have Daniel, my teammate. He's gonna do the presentation. Okay, so I just wanted to introduce myself, and then we can jump in if people have questions. So Daniel, if you wanna take it from here and share your screen as well.
Yeah, good. I was gonna say I need permission to share, but I'm good now. You guys see it? Everybody sees that?
Yeah.
Okay. All right. Well, so Raul introduced the company. I'm not gonna spend too much time on it. Just kind of a couple highlights. We are funded by VCs and federal funds. We're a funded startup running since 2013. We are 10 people, 16 in engineering, and right now our main product is a fleet management for universities and businesses, 3D printing fleet management. The NIH was mentioned here. We actually are integrated with that repository. We have presence in the US as well. And I'll show you an image later, or how AstroPrint is actually enabling printing from the web, from the NIH website. What we offer to this effort is our 3D printing cloud and expertise, our infrastructure to run the software that we're building. And we decided when the crisis started and decided to help in the best way we know, which is making software, and decided to dedicate our engineering resources to do this at no cost. And then for that, we created a product called AstroPrint Clusters. And then, so what is AstroPrint Cluster? Basically, it solves the problem that Raul just described. It's a product that will help coordinate the demand, the actual printing and the delivery to the places that need this. And the goal is to help rally the community, the local and regional community, to help create supplies within the limits that we all talked about in this presentation. Create supplies for these medical professionals that need them. We're currently focusing all of our engineering in getting this out so that it can be used. We are aware of the urgency of this. And we actually plan to launch something for people to start using it, and obviously we'll continue to operate and improve, but we will launch today. Quickly, this is kind of the workflow that our software follows. We basically give a tool to the regional coordinator that would basically be in contact with the authorities and make sure that they have approved designs and they are aware of the demand in the market for these parts, and they will maintain a library of designs that can be printed, and then people can join this cluster as makers and download the designs, print the part, report them as printed, assign serial numbers, whether it's by a barcode or simply writing a number on the part, and then send them make them available for pickup. The tool coordinates all of this. Then the pickup happens. They're shipped to a place where they can be tested and validated, not just the design, but now the actual finished part. Obviously, these printers sometimes don't produce the same results, even though they come from the same design. So every part probably has to be validated and then eventually delivered. So all of this workflow is managed by our tool, and then we will gather analytics to know things like, for example, which printers, which makers are generating parts that are potentially rejected a lot. In which case, those parts will those makers will probably have to be helped to produce better parts. or if you can also get a list of who's printing the most, so maybe you can other companies can donate plastics and things like that. So this is just ideas of where we're going with this. The next slide is essentially a couple of screenshots of what the product looks like. And my last slide just shows our integration with the NIH, which, like I said, it's been running for a while now. We were using doctors, we were helping doctors in the past print proteins and things like that with the previous designs that the NIH has, and now with this effort, we continue to be there. So I don't want to extend myself too much. Any questions?
No. Thank you very much, Daniel. I think it's wonderful what you are doing, powering us with your solution. I think that it's important to say that you have reached an agreement with the Spanish makers to use this tool as the general administration tool for printing. Is that right?
I think Raul has the latest on that, but I believe we're still waiting on a decision for that. We're regardless going ahead because we do have plans to use this in other countries as well, where we're present, but we have not yet gotten a formal go ahead from the Spanish makers just yet. We are launching this app today, and I'm pretty sure some of the local coordinators will use it. Our hope, of course, is that it will become at least a formal endorsement so that people know that exists. Everybody knows that it exists, and we can kind of coordinate everything in one place.
Sorry, Antonio. Go on. I was going to ask Raul if that could be connected to the app we're preparing in Portugal, which has a different. A more enlarged and different kind of approach. It's not only for 3D printing, so it's not only connected with 3D printers, it also includes the supply of materials for the printer people, for the makers or whoever, and is able to include also the mold injection, the suppliers of filament, of the screens, of whatever, and is going to be European wide, so not only each country. So I think if the two can connect, that will enrich both. Is that connectable or it's too close, Raul?
You should explore it. I can connect you both, and I think that you should explore it. We don't have time now to speak about it. But I think that
my question was only if it is open to connect. Okay.
Yeah, we're definitely open to connect with the other people that are trying to help as well. So yeah, as Antonio said, I'll share my email with you later, and we can take it from there to understand exactly what you guys are doing as well.
Thank you. So at least I need to leave in 50 minutes at 10 o'clock because I have another meeting. Okay, I think this is very interesting. I could give you the floor and I could let somebody coordinate, but I would like, before leaving you, try to speak about what will be the next steps if we think that the Joke's proposal is interesting and merits our support. Okay, so Joke, what will be the next steps?
I think one of the next steps is to liaise with you and also liaise with the people that are now making the what is this solutions pages, and see how we could create a similar kind of structure as the NIH has in the United States.
Totally agree.
Would you lead?
Yes, I'm perfectly fine in establishing this in close collaboration, I think, with your team.
Okay, it's not my team. It's that this is a volunteer group, but I will totally give you our support or the support of the European Cluster Alliance, just to be clear that it's not properly our team. Okay, here we have a lot of people from different movements, and that's the good thing about this team. Okay, but
sorry, one point that I think is important is to have a point to centralize all the information, okay? All the WHO information, all the academic information in the same point, because if not, everyone is going with OAKS, okay? And as I told you, to be academic for me and for the movement, I think it's very important. So working everything with official documents, it's very, very important. I think that not just having the STLs files or a validation process. And that's the other point, having a clear validation process, because here in Spain, we didn't have a clear validation process. And we feel that that lack of official process has going against all the healthcare people. That's thank you.
Yes, so indeed, so that's why I know that the Cluster Alliance is setting up this kind of web page and so forth. So I want to make sure that within that we have a centralized kind of point of contact and also a structure in terms of a repository that is compatible to that.
Perfect.
Antonio,
Ilaria,
it's Veronica.
If I may...
Veronica,
sorry, Veronica.
No, Veronica. Good morning from Italy. Ciao. If I may add something, emphasizing the need of this further step towards, let me say, a clinical level peers review. Because yesterday I spent all my day to have a framework in my territory. I contacted my companion from the cluster for life science and my region. And what I learned is that basically they are trying from the very first beginning to, let me say, to leave the makers, the bottom-up makers out, in the sense that they care so much to the good validation and real quality of all this stuff that they wanted to coordinate and orchestrate this. And also when makers have been called to give their support, everything has been coordinated by universities and, as you said, the meteorological laboratories and the like, not like simple citizens, because the kind of control that they are trying to do is to guarantee the real quality and the real functioning of staff in the very moment when between life and death. This is the point. Also, the kind of purchases that they are doing as criteria. The first criterion is that your business, daily business, is manufacturing or working in the medical device sector. So they are putting a bit together this and leaving the other stuff as a last resort. Also, they are going on with this kind of approach for fear, because again, they want to guarantee everything, the correct process and certified stuff, but also because they tell me that China has restarted manufacturing, and much of this kind of products usually come from China. In terms of certifications and validations, in fact, we were in the very first days stuck because we don't have many laboratories, or very few of them in Italy, doing this kind of certification, because other countries such as Turkey, for instance, are more organized to do this. And this is what also life sciences companies do. So, so just to say that it's very important, if we want to continue to push and promote the makers initiatives at European level, what Duke proposed is of utmost importance. Also in the USA, I was given some information from there. They are saying more or less this. So yes, it's nice, it's quick, the 3D printing, but at the very end, it can open more problems than the one it wants to solve. So just to say that there seem to be two different approaches, okay, to the problem. So the compassionate, okay, that's for me is always good. But when you want to interact and collaborate with medical environments, some of them are a bit closer. And I also learned that there is Ireland that is doing a good job to gather information on 3D printing of medical devices in the life science environment. So I will post immediately the link to this to the repository that they have created. That's it.
Thank you very much, grazie mille, Veronica. It's clear that this is the same kind of problems that we have here in Spain, as Alvaro and Dani and Miguel Angel can testify. Okay, I think the point is that we are not speaking only for the makers community, because at least here in Spain we have reached for near 1,000 companies, even big companies, that are putting at the disposal of the health system their installations, sometimes very big printers. Okay, and this is for an emergency. And I think that the point is to have the right level of quality assurance, to give them the possibility to print or to manufacture it very quickly, high level quality designs. I think that's the point, and not only for Europe but also for the regions even. Okay, but I totally agree with your speech. I don't know if someone wants to comment on that.
Yes, Anais speaking. I've been listening. It's very technical for me anyhow, but for those who don't know me, I represent the Life Science Cluster Association at European level. So we have a webinar on Thursday for all our members. It's also open. And I think actually maybe one of the points that I can bring to the table, and we could discuss maybe with one or two of the people that spoke today, if we could have this, let's say, relation with other ecosystems such as the makers or anyway, the 3D printing. Because I think since we work in the life science sector at all over Europe, it can be very interesting for the members to connect better, to know what's going on, and also to share, especially in the case of the Italian, but in the case of other country, how we connect with such ecosystems as the 3D printing, because I think maybe we can help also in making the links with for example, the hospitals or the medical doctors and the people that really work on the field. So I will try to think today and maybe invite one or two of you if you could come to the open webinar. I think that could be very interesting.
Yeah, that will be wonderful if Joke or whoever wants to comment or share with them tomorrow. Thank you very much, Anais. So it's time for me to leave you. You can continue, okay? I will not close the session. I think that we need to wait for Ulas until tomorrow, okay? But I will share your contact between yourself, and I think that we must take very quick steps. I know that all of you, everyone is taking very quick steps in this crisis. So it's just what we can do from the European Cluster Alliance is give you all the support that is in our hand. Okay. So thank you, everyone. I will leave, but you can continue. Thank you.
I also have to leave soon. So Antonio, I will connect also tomorrow just to.
Perfect. Thank you.
Yeah. Okay. So thank you very much. Good luck. Stay healthy.
Bye, everyone. See you soon. Take care.
Bye.
Do you want to continue with the session? Does anybody else want to share any information they have that would be valuable for the group?
I'd like to ask if the connection for the meeting Anais has just told about is the same as this one.
I
You know,
think it is. I think it is a different one because it is from her cluster. It's a different link, but I guess I'll ask her for the link.
Thank you, Nina. Because I'd like to participate. We're also on the life sciences side. So if you could share, that's wonderful.
Yes, I will pass it.
Thank you.
Is there anyone still online? I have a question about involving doctors in the discussion. Do you have any contacts with those who are actively fighting the disease and could be commenting live or even in this discussion on what they need most?
Here in Portugal, we are involving doctors. We are involving two types of entities. The official homologation agency, which takes much more time because they have to do more things and they have to document everything. So they take some time. They have several admin steps. And those that are really fighting for lives and for instance, in hospitals that are more busy with the contaminated people, they're so worried about not having the equipment that they connect directly with the communities, and we are working with them. So in each hospital, even before the official model is approved for the country, they analyze and they use it in each hospital. What I do care is about not having makers to produce without that, because it already happened that a group of makers got frustrated, of course, because they spent time, material, and willness, and they produced a lot of things. And when they came to the hospital said that that could not be used because it was not approved. So that cannot happen. That kills the will to do. So what I advise everyone is, even before they have the official model that I will send, as soon as the local the country agency approves, they have to get the approval of each user, of each hospital. So doctors are working on that. Everyone should do the same, should get approval before doing things.
And I think it is very... Okay, sorry.
No, go ahead.
One of my points is different users have different needs. We've been speaking much more only on hospitals, and of course that's the more urgent thing to solve, and there's where this fight against contamination is more worrying us, because doctors are so exposed and nurses, and we cannot afford to have them heal. But also the spread of the contamination can be controlled if other agents of public needs are also protected. And that's why I keep talking about firemen and policemen, because on the streets the contamination can happen. When people go to the hospital, they got the disease outside. So those are less close and less exposed on a full moment time, so they can use less demanding equipment, protection equipment, and we can help them.
here in Spain, the doctors are in contact with the makers. Actually, all of the people that you saw here, Miguel Angel and Alvaro, they are scientists themselves, and they have all of them working with hospitals. And yesterday we were in a meeting with 45 initiatives of respirators that are being designed, and half of the people were doctors actually from the hospitals. It was a Zoom session with little thumbnails of the webcams with the people actually inside the hospitals with their masks and their robes and the scrubs. So all of them are working with doctors. If we see that we need to involve some doctors here, which their time is really scarce, and their energy also, because they're really busy actually saving lives, we could suggest, and if some of them are available, but we should get to very specific requests from them, I think, in my opinion.
What is important? Okay, sorry. Well, just a short note. I think it's of utmost importance to select the priorities which makers should work on. Yeah, that's what doctors are needed at as much of steps as possible from my side, just to keep us in balance and in focus of most important stuff to do. Like, for example, the respirators, is it the most important or not? Are there enough coming on? That's a question that we are still balancing. Is there something more important and urgent than making a 3D printing respirator and so on?
I can comment on that.
Sorry, Vasco speaking. I'd like to stress what Aurora mentioned, because sometimes we are focused really on the doctors and nurses in the hospitals. And as she mentioned, the people arrived there because they were contaminated outside of the hospital. And so if we look also to the policemen, to the firemen, to the people in the ambulances and so on, maybe it's also worthwhile, well, an important way to restrict the diffusion of the disease.
Miguel Angel, you wanted to say something?
Yeah,
if I saw correctly.
Only the rest is okay with that. One thing is, of course, doctors, nurses, and all the staff in hospitals are the ones that are basically our targets. At least that's my case, and they are very difficult to involve in the research and development itself, precisely for the reason, because they are already very stressed by the situation. They cannot be doing tests for us over and over. So we do this only in a very limited way. So we contact them when we have a prototype, and like this, when we think, basically when we are mostly sure that the prototype is worth of their time. That's one thing, and then the other is about what I think that in the end is a general idea around in this forum, is about we are addressing these as makers, or we are addressing these as scientists, and I think that both are needed. Both are totally complementary, one to the other. That's, for example, at the beginning of the presentation, I was when they were presenting about these micropores in the material. This is a very applied scientific question, and there is already evidence there to work with. So we shouldn't be only makers. This is my opinion only. That we shouldn't be only makers, and if we find a wall, then we turn 90 degrees and say another question. No, we need to sit, we need to read papers, we need to go for the bibliography, because most of the time the questions already were made before, and most of the time the questions are answered in some papers there. So we need to invest time there. That's my opinion.
Okay. If there are no further questions.
Nina, I'd like also to connect with Álvaro because we're very aligned in all the vision. So I'd like to exchange ideas and practices with Álvaro. So if you could send also his contacts, that would be fine.
Yeah.
Thank you.
I've written it down.
Well, thank you all. Everyone is so quiet that we all have so many things to do.
I also take it as a sign.
Time to go, no?
Yeah. Goodbye,
Okay.
everybody, and thank you very much. The next meeting is tomorrow at 8:30 on a different subject, but I think the discussion
Sorry,
about
I have
3D
something
printing
to
will.
Sorry, Nina, I have something to add. As 3D printer developers and owners and network of 3D printer in the country, we've also been asked by several groups that are developing vents so that we can produce parts, components for those vents when they become industrialized. So that's something that also the community of makers can be ready to do, and that as less demanding porousness. I'm missing the word. I'm too tired. Porousness capacities. So parts for vents can be made with high infill to be strong, but the porousness of that is not important. Okay.
Okay. Do you have any specific next steps for that? It's like I can't really follow what would be the necessity in that area right now.
What we need to do is only to let the community of 3D printing owners knowing what is needed, and the guys that are producing the vents have to send the the STL files, otherwise no one can produce.
Okay. Can you send us an email with that? That would be great.
It's in my presentation that I sent to Antonio, but he had no time to let me present here. But Antonio has it. I can send to you too if you send me. I have your email, sorry.
Yeah, you should have it.
I can send to you too because my presentation is more general, is more global, and is more on presentation of the organization. Of course, as we are 3D experts, I also have this part, but it's more global, so I include all of these. I'll send to you. Okay.
Okay, thank you.
You're welcome.
Okay.
Bye all.
Then
Bye-bye,
thanks
everyone.
again. Goodbye, and
See you
maybe tomorrow.
Okay, bye.
Bye.
Bye.